All right, so I've kind of redrawn what we did in our first video. We have our truss. We have all of our angles figured out. We figured out there's an up force at A of 350 and an up force at C at 150. Those total added up to 500, which balanced out our 500 going down at D. So all of our torques and lefts and rights and ups and downs were all balanced, and we are now ready to officially start our truss problem and try to figure out the internal forces in 1, 2, 3, 4, 5, all 5 of the members is what we want to do. So I thought we'd start over here at joint C and try to make sure all the forces are balanced around point C. So what we have here, so this is, it's fun, I think. You got to be a real detective. We have an up force of 150 right here. We know what that one is. So we have some kind of a force in this member here, and we have some kind of a force in this member here, and those are the only 3 places. We have just 1, 2, 3 things. Okay, so now we have to decide is the force in this member right here, is it going like this, or is it going like this? We have to determine which way it's going. It can only go one way or the other. Likewise, this one here, it has to be coming in like this, or it has to be, going up like that. So which one is it, and how do we figure that out? Okay, well, we know we have 150 going up. We have 150 going up. That means we need 150, at least 150, going down. So where could a down force of 150 possibly be? That tells us what kind of a force this particular one right here is. Because you'll notice that this force here is at an angle. And we're not going to leave any forces at angles. We're actually going to resolve them. And remember, we did this when we were talking about vectors. We're going to resolve forces into lefts and rights and ups and downs. Lefts and rights and ups and downs. So if I have, I'll redraw that one like coming up at an angle. So I can say that this force here, either it does one or either thing. It either goes up and then over. Okay, that's one possibility it could be doing. Or the other possibility is it could go over and down. So which one is it? Which one is it for this particular force? Well, it has to be the over and down. How come? Because here already on C is 150 up, and I need 150 down to balance that out. So that's how I know that this particular force right here is going to be a force going, and I can redraw it. I can draw it right on here. It's going to be a force going over, and it's going to be a force going down. And I actually right now then know what this force is. It's 150. This part here is 150. Okay, I'm going to erase that and make that look better, I hope. Having a hard time writing with this thing. Okay, 150. All right. So I can if this is 29.8, then that means, and this line here is parallel to this line. If this is 29.8, that means this is 29.8 because they're alternate interior angles. Hopefully you remember this geometry. That's 29.8 also. Okay. All right. And because I know this angle, and I know that this opposite side here, okay, is 150, and this is a right triangle, we're going to deal with all right triangle trig, then I could figure out what this side over here is. We'll call this x, because the tangent of 29.8, the tangent of 29.8 would equal the opposite, which would be 150, over the adjacent, which would be x. So the tangent of this angle would be the 150 over x. And so x would equal 150 divided by the tangent of 29.8. And I can figure out what that x is. 150 in my calculator. 150 divided by 29.8 tangent equals, I'm just going to check that math again real quick. 150 divided by 29.8 tangent equals, I get like 262. So this force coming over this way is 262. So what that means is that this force here, this member right here, it's going over to the right and it's going down, which means that this member is, the force is going down towards C, like this. This is the way it's going. And when you do that, once you have a side in this member figured out, you can go up to the other end of the member and you can draw a force going the opposite way to that. This is the only way we can have it. You can have them both going towards the points, or they're both coming towards each other. That's the only possibility. So this is going this way and this is going this way. And then, so what kind of force is happening in this member BC? Is it tension or is it compression? And if you remember in our last lecture, if we have a member like this and the forces are going away from each other, that looks like tension, but what it's really doing is compressing the joints. So this is actually compression, and it's going to be a negative number. Remember, compression was negative. Compression was negative, and tension was positive. Tension. The T looks like a plus sign. So tension was positive, compression is negative. Because these things are going away from each other in this member, this is going to be compression. It's going to be a negative number. And I can figure out what it is really easy. How do I do that? Well, I have a right triangle here. That's a side of 260, and this is a side of 150. So what is this side? Well, it's Pythagorean's theorem, right? So it'd be 262 squared plus 150 squared. Square root that would equal that side. So 262 squared plus 150 squared equals square root, and I get 302. Now remember, this is compression, so it's going to be negative. So it's going to be 302, negative 302, whatever it is, pounds, newtons. I don't know what it is. I think it's pounds. Okay. And if you happen to have your book, I have all the solutions written in the book. So the answers are down in 5.22. And that was correct. BC is negative 302 pounds of compression force. Okay. Now, so if this was 262 going to the right, now everything has to be balanced, right? So what do I have? I have 150 down and I have 150 up. Good. Here I have 262 to the left. So what does this have to be? See, we know what this is now, right? This is 262. And because I know what this is, I can come to the other end of this member and do this. And I know that the force right in here is 262. Is it compression or tension? Now they're going towards each other. When they're going towards each other, that's kind of pulling on the joints. So that's going to be a tension. So for CD, it's going to be a plus 263. Plus 263. Now, we're kind of dropping these out real quick now. Now here's actually a pretty easy one. Down, I have 100, or I have 500. So what does this one up have to be? Well, it has to be 500. Right? It has to be 500. And if this one's going up 500, then I come up to the other end and I draw one down. And here I have a tension. And so BD in here is, let me erase that there. BD is a plus 500. So there's the answer to BD. Okay? So BD, I'll write it down here. BD equals plus 500. What else did I have? I had BC. BC was a negative 302. I had a DC was a plus 263. And let's look at AD. What do I have for AD? So if this is plus 500, if this is 500, This is 500 down. Those are balanced. This is a 263 going the right, so this has to be a 263 going to the left. And so that means I come over here and I can put an arrow like this. These are both pointing towards each other. That is also tension. So that's a plus 263 also. Okay, so that's AD. So I can put that in my list. AD is a plus 263. See, a lot of times once you figure out one of these joints right here, everything else kind of fell into place pretty easy. The only thing we have left is AB. That's the only thing we have left. And I think I'm just going to keep going. This video is, I'm only up a little over 10 minutes, so I'm going to keep going. Give me some space here so that we can figure out this last side here. Okay. So what do we got? We have right here, this is pretty easy, I think. We have an up force here of 350, right? And we have one going to the right here of 263. The only other option we have is this line right here. So is this, and I'll redraw it twice. So we have to say, is AB doing over and down, or is it doing up and over? Which one of these is it? I'm waiting for the answer. Are you yelling it? Okay, so if this is going up at 350, I need a down, right? I need a down. And this is going over the right, so I need a left, right? So this one has to be over to the left and down. And right now, I know what this down is. It's 350. Has to be balanced out to this, right? I even know what this left is. It has to be balanced out to this 263, so it's 263. I even know what that is, okay? So I didn't even have to use an angle here on this one. That was pretty easy, and I can just use Pythagorean's theorem there. So 263 squared plus 350 squared equals square root, and I get a 438. And which way is this? Okay, so this is going over and down, so that means it's going this way. That means I can come up here and draw the arrow this way. They're going away from each other, or they're compressing the joints, right? They're compressing the joints. So this is compression. This is going to be a negative 438. So my last one, AB, is a negative 438. A negative 438. Okay. So that's kind of how the E-Lab is going to work. I'm going to do more videos, I think, on those E-Lab problems, because this is challenging. You're going to get stuck. It's going to be rough. Please post in the Discord which ones you're having troubles with, so I can just kind of make little movies for you and show you where you're maybe kind of going wrong or something. But generally what's going to happen is you have an E-Lab, and I'm going to have like 5 problems in there. It'll say like B, C, and C, D, and B, D, and you're going to have to put in either a plus or a negative answer. I believe in the E-Lab, I'm not actually even asking you to put any units. I just want you to put a plus or a negative force in there. So it's either a plus tension or it's going to be a negative compression. That is how you do truss calculations. So you start by balancing lefts and rights and torques and ups and downs. And once you get all that all worked out, you can begin your truss problem trying to find all the internal forces in every single member. Good luck.